how does Metawave's technology improve 5G connectivity?
5G is going to be driven by high data network. For example, especially with COVID, with online learning and everybody collaborating from home, there is a huge intense data driven by the video, for example. And the problem is in today's network, you have very limited access in some region. On the top, you have that little square. It looks like a picture frame. You can actually cover it with any kind of paintings or advertisement, and it looks like a very friendly device. But what it does, it extends the range of the millimeter wave 5G indoor radio, because most of the video consumption is going to happen indoor initially. And we're very happy to be the first one to demonstrate it and have successful trials both in the United States and abroad, especially in Japan, successfully. And this has zero power consumption. Efficiency is going to really explode with the millimeter wave 5G that has 1,000 more capacity than the 4G network. And you just cannot solve the problem by adding more radios. So the passive reflector will reduce this number of radios as much as half. And then below that, that little square is the active repeater, purely analog active repeater. Both they have near zero delay, and they also the repeater consumes very low power. Consumer especially is always concerned seeing more and more radios, more and more antennas everywhere they turn their head. But if they see a passive reflector that looks like a picture frame, is much friendlier. And in addition to the cost, we're talking about a cost that is a couple of $100 compared to few thousands of tens of thousands of dollars compared to a radio. And the same thing with the turbo, repeater. Millimeter wave, a completely new dimension, and learning on the spot when you roll out. That's what the carriers are doing today. They are frustrated, and hopefully our solution will enable a much faster growth and more efficient and effective rollout of these networks.
We're going to see an explosion of connected devices as 5G rolls out. So, how do your devices handle all of that traffic?
The beauty of Maxwell's equations or analog repeaters and relays is that we don't process any bits. We are not subject to Shannon capacity. So whatever information comes in, we amplify it. The passive reflector can amplify it as much as 40 dB, and the active repeater can amplify it as much as 120 dB. So it tells you how much the signal can be boosted.